Welcome to section 10, the section on chemical reactions. This is the first of several videos, and this one will be on what is called composition and decomposition reaction. The goals for this set of videos are the following. We're going to be able to define what a reactant and a product is. You'll be able to understand what a chemical reaction is. You're going to know the four possible states of the reactants. You will be able to identify the reaction type, and towards the end be able to predict what the reaction will produce. So our first definition are reactants, the chemicals which will undergo the reaction. This is somewhat circular, but to put it another way, these are the chemicals you start with. The products are the chemicals you end up with. The reactants react to produce the products. For example, here we have hydrochloric acid, HCl, and sodium hydrogen carbonate, NaHCO3, and they will react together to form table salt, NaCl, plus water plus carbon dioxide. The hydrochloric acid and the sodium hydrogen carbonate are the reactants. The sodium chloride, the water, and the carbon dioxide are the products. The reactants are always to the left of the arrow. The products are always to the right of the arrow. The hallmark of a chemical reaction is that because atoms are being rearranged by breaking old bonds and making new bonds, what you start with is not what you end up with chemically. You end up with different chemicals with different chemical and physical properties. So for example, I can take hydrogen and I can take oxygen. If they react, they produce water. Hydrogen, highly flammable. Oxygen makes things burn better. Water puts out fire. What you start with is not what you finish with. Now there are four possible states of reactants. The reactant could be a solid, abbreviated S, and that would be a pure compound. If I put a bar of iron out, it will react with oxygen. The iron will be solid. The reactant could be a liquid, that is abbreviated L. It will also be a pure compound. For example, I can allow methanol or wood alcohol to react with other substances, and methanol is a liquid. The reactant could be a gas, abbreviated G. This is also a pure compound. For example, if I allow the iron bar, which is solid, to react with oxygen gas, you'll get rust. The solid is reacting with the gas. And the fourth state is aqueous, AQ. Here the reactant is dissolved in water. For example, table salt or sodium chloride dissolved in water. We would say that is an aqueous solution. It is a homogeneous mixture, and in the reaction, the water will not be part of the reaction. So, for example, in our first reaction, it is better to write it as two hydrogen gases plus oxygen gas produces two water liquid molecules. And so you write the state of matter, and so you write the state of the reactant so you write the state of the reactant next to the reactant. So here, solid copper, aqueous calcium iodide produces aqueous copper 2 iodide and calcium. Here, magnesium carbonate, which is a solid, produces a solid and a gas, magnesium oxide and carbon dioxide respectively. And in this reaction you can see that all four types of states of reactants are present. We have sulfuric acid, which is aqueous, that's the first reactant, barium carbonate, which is a solid, and they react to produce barium sulfate, which is a solid, liquid water, and gaseous carbon dioxide. So now let's talk about the 5 types of chemical reactions, and all chemical reactions can be broken down to these 5 types. The first is composition, sometimes called synthesis or combination. Second is decomposition. Third is single replacement. Fourth is double replacement. And number 5 is combustion. And in this video we're going to deal with the first two, composition and decomposition. So composition reactions, basically two or more substances react to make one substance. Many reactants become one product. A plus B becomes AB in the generic form. You will only have one product. For example, 3 hydrogen gases. For example, hydrogen gas can react with nitrogen gas to produce ammonia. Iodine, solid, can react with aluminum, solid, which produces aluminum iodide, which is also a solid.
In this video, I'm going to do a quick demonstration of what happens when you combine iodine and aluminum. They react together to form aluminum triiodide. So what I got here is about 5 grams of iodine that I've crushed into a powder and about 1 gram of powdered aluminum. So we're going to mix both of those together thoroughly. And this generally takes a few minutes to start the ignition because it takes a while for the activation energy to be reached. But I'm going to speed that up a little bit. So now we'll start it with just a couple of drops of water. Well, it actually looks like 1 drop was enough. See, here's the products of the reaction. The aluminum iodide, it's still smoking a little bit with iodine.
So that was a composition reaction. A decomposition reaction is the opposite of a composition reaction. One substance, one reactant, will react to make the more than one product. Generically, AB will break down to form A plus B. There will only be one reactant. You will have multiple products. For example, if you heat up solid magnesium carbonate, it will break down to form magnesium oxide and carbon dioxide. Hydrogen peroxide will break down to form water and oxygen. And you've seen this with the puking pumpkin demonstration, but just to ensure that you remember what it looks like, we have this video.
From Boston, please welcome Science Bob Flugfelder. Hello, Science Bob. Thank you for coming. That's a good-looking jacket you have. Is that a tie-dye?
It is tie-dyed, yeah.
Can you buy that, or you have to make that?
No, I actually made that.
You made that?
The first and only thing I've ever tie-dyed.
Well, you know what? It's a winner.
Thank you.
So tell us what we're going to do here.
Right,
I know you're a teacher.
Yeah.
What grade do you teach?
Elementary level, which is somewhat unique.
And the kids go nuts they like to see weird stuff happen.
Oh, yeah, yeah.
Me too.
We don't sit and read a whole lot.
Yeah, that's me either. That's exactly what I like. So that's why this is going to work out so well. What is our first experiment?
All right.
Is it really an experiment?
No, it's a demonstration.
A demonstration. Okay,
yeah.
very good. All right.
All right, so we're going to do a little, we're going to basically break apart molecules.
Good.
Yeah. And we're going to use hydrogen peroxide, but it's not what you get in the store. Hydrogen peroxide is actually H2O2.
Okay.
So H2O is water. They put an extra oxygen on it, you got hydrogen peroxide.
You get a weaker version in the store?
Because
I used to intentionally cut myself so I could pour
the bubbling?
So I could sizzle up my...
Yeah, the stuff that we use will actually give you a chemical burn.
Okay, so don't use it.
Don't.
Okay, great. All right. So, all right, so what do we do?
We're going to get started. We're going to start with a little bit of, actually, dish soap. So if you want to put some dish soap in your flask.
How much? Just a squirt?
Yeah, a little more. That's good.
Okay.
So dish soap will keep the bubbles because we're going to remove the oxygen. They'll hold the oxygen.
Okay.
So I'll put a little bit in here. All right. Next, coloring. We have green and red. Do you have a preference?
I'll take red.
All right.
Very Christmassy. How much of this?
And just keep going. Keep adding a lot of that.
Okay.
That's good. A little more.
This is going to be delicious.
All right.
Is this how you did your jacket?
That's good there.
Okay.
All right, so I'm going to add the hydrogen peroxide because you don't want to do that.
Okay. Oh, it's dangerous,
This
right?
is
Okay.
dangerous. And actually, yeah, let's get all geared up here.
Okay. Good. Put these on my eyes.
There we go. All right, so in goes that. And
Now, what's happening here? What process are we about to see?
So here's what we're going to see. We're going to, in order to remove the oxygen, we're going to use a catalyst.
Okay.
The catalyst will speed up the reaction. So we're going to, that's what's in here. It's a sodium solution. We're going to pour that in, and that's going to remove the oxygen. The soap is going to hold it,
And we're going to smother to death, all of us.
it'll be okay, but it will create a lot of bubbles really fast.
Okay, great.
And usually this is done in graduated cylinders, but we're going to make it a little more intense with these ridiculously large flasks.
Okay, good.
All right. So this is what you're going to use. We're going to pour that in there. The oxygen will be released, and we'll watch the reaction. We're going to need to step back after we pour it.
Okay.
All right. Here we
Step
go.
back.
Ready? In 3, 2, 1, pour. There we go.
Whoa! Whoa! Wow, that's great. It's like Ghostbusters. Wow. Whoa!
To review, the reactants are the chemicals that undergo the reaction. They will be to the left of the arrow. The products are the chemicals that are made in the reaction. They'll be to the right of the arrow. So for example here, the lead 2 nitrate and the potassium iodide are the reactants. The potassium nitrate and the lead 2 iodide are the products. The hallmark of a chemical reaction is the chemicals you start with are not the chemicals you end up with. The atoms get rearranged, and the products will have different physical and chemical properties than the reactants. Remember, there are 4 states of reactants: solid, liquid, gas, all of which are pure, and aqueous, which is a homogeneous mixture. And remember, the water it's mixed in is not part of the reaction. The 5 types of reactions: composition, otherwise known as combination or synthesis; decomposition; single replacement; double replacement; or combustion. We did composition reactions. Many reactants become one product. This is the generic form. And here's an example of how you make sodium chloride or table salt. Decomposition. One reactant becomes many products. Here's the generic form of AB becomes A plus B. And here's a reaction you guys are used to seeing. Carbonic acid, which is aqueous, will decompose to form liquid water and gaseous carbon dioxide. How do I know that you're seeing this? This is the reaction that causes carbonation or the bubbling in soda. So we've covered 40% of the reaction types, composition and decomposition. In the next video, we'll do 2 more, single replacement and double replacement.